The Yu-Chen car wash did market research to determine how much to charge for a car wash. The company made this table based on its findings. So I see that the function table has a price per wash in dollars and then the customer's expected per day. So A says graph the price, expected customers, data, draw a line that models the data pattern. So if I take a look at this, the first thing I want to do is go ahead and graph, and I'm going to figure out if there's a pattern. So if I see that price per wash in dollars, then customers expected per day, the customers expected per day depends on how much it's going to be paid, or the price per wash. So I'm going to go ahead and put customers expected per day here. On my y-axis, and then the price per wash here. I notice that it goes from 0 to 20. I'm going to go ahead and just count by fives on the x-axis. And for the y, I notice that it goes from a range of 20 to 100. So I may actually be able to count by tens to see if I can reach 100. So I just need 10 lines. And that's perfect. So I'm going to go with 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And so now I can start graphing. So at 0, it's at 100. At 5, it's 80. At 10, it's about 65, so between 60 and 70. At 15, it's 45, so between 40 and 50. And then for 20, it's at 20. So I noticed that this is a very different type of graph that we're used to. We've been working on a lot of positive correlation graphs, but this one seems to be going negative. So if I need to draw a best fit line, I would have to go ahead and draw something that would go downwards as opposed to upwards. I also noticed that I already have a y-intercept, so I'm going to go ahead and use that in my favor. So I'm going to use the 100 and then pick another point on here that would give me my best fit line. So I think I'm going to pick this line here. And remember, we're trying to cross as many points as possible. So that's my best fit line.